Oh, good news for the AI and Quantum Lab. Last night, one of our launch projects, the project that applies artificial intelligence to matching cancer patients to clinical trials, had their first round of funding at the Medical College of Wisconsin, and they got $400,000 for 10% of their company.
That's a lot of money.
You made the company.
I did.
Okay.
But we have two CS interns, Caleb White and Ben Wren. Let's say mostly Caleb.
Are they all part of it, or are they just gonna?
No, they're gonna work on things unrelated to the core AI stuff, and then two Masters of Computer Science alum uh, that are one of them is a senior software engineer for a company. The other one owns a research company, so they're also involved in the project. So cool things.
Amen.
All right. So I think I said we were going to start talking about threads. Does that sound right? I was going to say something about multi-threading. Okay. So first of all, tell me about the abstract keyword. Oh, I have no drink. Oh, sad day. Snip the markers. All right. So tell me about the abstract keyword. What's that guy for?
When you made that one class abstract, it did not allow us to create an object in the driver class.
Okay, so abstract means that, well, any class that's abstract, you cannot create direct instances of that class, which means that class exists solely for inheritance. Okay, it's meant to be a building block. Okay, so we have built off of that guy. So, Java gave us this thing called an object, of which all objects are meant to be built off of. We then created this abstract class called entity. So maybe that's in what is that? Is that magenta? What color is that? Purple? No, it's not purple. All right, it's magenta. He's wrong. He has to be wrong. All right, so we have this abstract class entity that we never intend to make one of those, but we intend to have things that are those. So we made one player, and now we want to make some NPCs. Now, realistically, we could probably make NPC abstract, because we might say that really, you know what, an NPC is kind of almost too generic. We're never going to actually have NPCs walking around. We will have things that are NPCs walking around. Let's see what we've done with NPC here. So we decided that all NPCs have a defense, which means that we can punch them and it hurts. All right. There's a lot of violence here at a Christian university. So that's all Old Testament stuff, fire, brimstone. All right. So this is Book of Daniel. Just take a peek in Revelation. All right. So, but realistically, we're never going to actually make NPCs. We're going to have things that are NPCs like monsters. So we should actually be able to say an NPC now is also abstract. So NPC is an abstract class that extends an abstract class. Go ahead.
You have overcomplicating the logic, but wouldn't that also pertain to player? Like, don't we not have an instance of a player as such, but we have iterations of player? You know what I mean? Like, how is that true for NPC?
Well, there's a player. We're creating instances of those guys.
Right.
So we can't make that class abstract. Otherwise, we couldn't do that line. We can't make one of those. I think I think maybe the confusion is what do we intend to do with NPC? So a player, we already got that guy going. That's our keyboard. We're controlling that dude. And if we go to if we keep evolving this and go to a multiplayer system, you'll still have multiple instances of players. Now you could, and maybe this is where you were going with it. You could say we're going to have fighters and mages. So there'll never actually be just the generic player walking around. Every player has in games we call these classes. So players are either fighters or mages or bards, whatever it is. So to your point, in that case, then a player would be abstract because we never intend to actually make one of those. So I that's fair. Which actually would then mean that in our example right here, we actually could say that NPC shouldn't be abstract yet. Because at this point in time, NPC and player are kind of the same animal. So what we're going to do is we're going to have different things in the room. So if we kind of think about where we might go with this, we might have things. So the idea of an NPC is something that is, let's say, alive, quote unquote, yet it's not controlled by a player. So it's a non-player character. And those can come in the form of like monsters, but maybe they can also come in the form of maybe interactive, I don't know, object, let's just call it interactive. So maybe there's like in the middle of a room, there's some kind of orb that if you touch the orb, something happens or whatever. So technically it is something that we can interact with. It's kind of a living thing-ish. So maybe we can go down to that line. But I think you make a good point. At this point, these guys right here don't really exist yet. We can always go back and make them abstract later. So let's go with that route just to keep things relatively clear. So for now, at least, we will make it such that anything that's not us that's in the dungeon is an NPC, something that's not controlled by us. Just for NPC. We're leaving it on entity. Realistically, the farther we go into this game, NPC will likely become abstract. And as he pointed out, player probably would too, as we create more specialized versions of what a player is. You wouldn't just have this guy walking around that's nothing but hit points. Although that's technically a tank, I guess, in a game. Okay. So in any case, we might want to have something. Let's just go into let's look at NPC real quick. So an NPC has a name and they just well, not even randomly. They get 13 defense. That's what all NPCs have in our world right now, but they have a name. All right, so we'll go into driver. Actually, let's just do it in dungeon. We don't need to create it out in driver. So as we are building our dungeon, we can go ahead and maybe say, let's create a NPC. Let's call this rat is equal to a new NPC rat. That's his name. All right. So well, that would be like the rat boss would be Master Splinter. Well, this is the entry level rat. This is the boss is going to be at the end of the dungeon. Yeah, we can't have
His grandson.
just all right, so we have this NPC called a rat. Now, NPCs look like this right now, but they get all of their abilities from entities. So yes, they take in a name. We're actually allowing our parents' constructor to set the name for us. So if we go into entity, we see what else this guy gets. This guy he has a name, but he also gets a current room. All right, so now what do we do if we want to add this rat to a room? Go ahead.
We do rat dot wait. Wouldn't it be rat dot current room equals whatever we choose?
Well, how does the room know about the rat? Up to this point, it's been a two-way street, right? We've had a room, we've added the player to the room, and what that does is the room sets his current player to the player that was passed in, but then the room lets the player know about themselves by passing in this. So here's our room right now. Rooms can hold a player, but they actually can't hold an NPC, right? So we have to re-engineer the idea of a room and decide what does it mean for a room to be able to hold an NPC. So for right now, we can just say, well, the room is only going to have one NPC in it. Realistically speaking, in an actual game, you could be attacked by a pack of rats. So the room might have a whole bunch of NPCs in it, right? But just to kind of limp into this situation, let's say that a room can have 0 or 1 players and a room can have 0 or 1 NPCs. So that means we need to now teach a room how to hold an additional thing. All right. So we're in room here, and we're going to say that a room can hold an NPC. Let's just call it the monster. Or actually, it's called the NPC since we're probably going to be expanding it. So they can hold an NPC called the NPC. We will initialize this just like we did with the player. So when a room first comes into existence, the NPC doesn't exist. We have a bucket capable of holding one, but it's not there yet. All right. So now inside room, what else do we need to update? Well, we got display. Right now, our display does what? It says, here's the name of the room. If there's a player in there, it says also here is this player. It also shows us what the obvious exits are, north, south, east, or west. But go ahead.
Could you basically copy down the original this dot player? If this dot player is not null, and then just change the player to the null or the NPC.
Yep. So we'll add an additional if statement here that says if the NPC is not equal to null, then we'll say, we're saying kind of also here, maybe we need to have another line that kind of, maybe we call it enemies. We're just going to assume that all NPCs are bad guys right now. So we'll say enemies, and it'll be this dot the NPC dot name. All right. So now our room can display the possibility of it having a single NPC. So if there's one in there, it has that. Okay. Now again, an NPC is an entity. So the only new thing an NPC brings to the table is that NPCs have defense. Go ahead.
My question is, how come we created the rat object inside of dungeon instead of inside player?
Well, it wouldn't be inside player, maybe in driver is what you're talking about, where we created our player.
Well, it makes sense they're not necessarily players, but I just thought since they were like characters inside of the game that we're making, that they would be called inside.
Well, wouldn't they be inside the dungeon? It's because the monsters, the NPCs don't live inside the player, they live inside the dungeon. So, and we're just kind of hard coding a rat. He's born in the machine, something like that. All right. So an NPC, all an NPC does, he further specializes himself from an entity with a single variable, defense, that we're just hard coding to 13. So we got to go up to entity and see what else is one of these guys. Well, he has a name. He also has a current room. Okay, that's what an entity is. So now inside of room, we're not saying that the player is an entity. Would that still work? Entity. Instead of the player being a player, can we say it's an entity? Is player an entity? Yeah, it is. So we could say that. But what does that mean? That means that the player, we can add anything for player that is an entity, which in this case could also be an NPC. Okay, so you can go down the tree, but you can't go up the tree. So we don't want to let our the player be equal to any old entity. We want it to be a player or more. As we were kind of foreshadowing, maybe we end up with warriors and mages and all that stuff. But for right now, our best stab is that this guy is a player. Now we have a way for players to get into a room. We're almost. So we have an add player. So a room, we can call a room's add player function. We can pass it a player we want to add to the room. It will set this room's player equal to that player. It will then let that player know that his current room is this room. the room that we just added him to. And then it does some printing out that so-and-so walked into the room and displays the room and that kind of stuff. All right, so if we want to be able to add NPCs, maybe we add a similar function for NPCs. All right, so I'll copy this guy as our starting point. We'll call this guy add NPC. It's going to take in an NPC as a parameter, and we'll call that guy NPC. Nope, still there. Yeah, I just used that as my starting point. So instead of setting the player, we're going to be setting the NPC equal to whatever NPC was passed in. We're going to let that NPC, we're going to set that NPC's current room equal to this. Now, do NPCs have current rooms? Because they got it from their entityness, right? So entity is the guy that knows about current rooms. All entities can be in a room, but only some entities are NPCs and others are players. All right. So we'll go ahead and say the NPC's current room is also this room. And then we're going to say the NPC.name has walked into the room. And we'll display the room again, whatever. Things get a little wordy on the screen. We can always make that better later, but it doesn't matter. Go ahead.
While we have put this, at the end of this dot, the NPC dot current room instead of.
Yeah, what is this? What is this keyword?
I think it's targeting the.
No, just what's the definition of this? Not in this particular instance, but just in general, what is this?
Like yourself.
Okay, so this is how an object refers to itself inside of itself. Okay, so if I'm an object and I want to refer to myself, human beings would usually say I or me. The computer jargon version of that is this, you know. All right. Now, what class are we in right now? We're in room. All right. So inside of this classroom, specifically, what does this equal? The generic definition of this is that it's how any old object refers to itself inside of itself. But in this case, we are specifically inside of a room. So this is how this particular room talks about itself. So down here, your question was, why did we put this? Well, because who is this? This is a room. This keyword is how this particular instance of room refers to himself inside himself. And what are we doing? We're setting this NPC's current room not equal to something like this.name. That's this room's name. We're setting it to this room, which is this. It's himself. So we're letting that NPC know that your current room is me. But instead of hoisting the entire room over there, we're giving it a pointer to where that room is. Because if we were to print out the value of this, we'd get a weird memory addressy thing that is like a room at memory addressy thing. All right. So the word this, even though it looks a little funny here, it's exactly what we want. If we're setting the NPC's current room, its current room should be a room. And we are inside of an instance of room here. And the way that we let him know about this particular room is just by saying this. All right, so we'll let this room's the NPC equal to the NPC. We'll let the NPC's current room know about this particular room. We'll do some stuff out to the screen, letting him know that so-and-so has done something, whatever, and go from there. All right. So now we have the ability to add a rat or add an NPC into a room. And we also updated rooms display to now support NPCs. And we just call all of them enemies. They're the bad guys. All right, so now we should be able to go back to dungeon where we've created our rat. and we should be able to add him to one of the rooms. Let's go ahead and add him to maybe R2. So he's a little bit further. Actually, we'll add him to R3. He's right there at the intersection of the cross. All right. Remember, and here's our map right here. Here's R3. So we're going to put the rat in here. All right. Now, right now, rats don't do anything. So we put him in R3, he's going to stay in R3. And nobody's controlling him because we're not controlling the player and the rat, right? It's the player that has this keyboard access-y type stuff. You know, we're going to expect the rat, well, right now, we're going to expect the rat to just sit there and wait for us to come beat him up, even though we haven't even written the beat him up code into it yet, right? He has defense, we have hit points, but nobody can take swings yet. Nobody's blown the whistle. All right, but we're going to put him in room 3, so we have him there. So we'll say R3, which we had created up a little higher here, and then we linked all the stuff together and things like that. But we do have access to the variable R3 here. And we'll say add NPC, and we'll pass this guy the rat. All right, so the player got put into R1 when we entered the dungeon with the player. So he's going to be in R1 like he was before, which happens to be the entrance. So I'm saying R1, but he really gets put into the dungeon's entrance. But in the constructor of the dungeon, this dungeon is born with a rat in room R3. When it came into existence, there was already vermin. Okay, this is a dangerous, dangerous place. All right. So if I run the code now, new entity. Oh, I was showing you where we couldn't do this last time, remember? Abstract class can't create instances of entities. So this was left over from last class. So we'll not try to create an instance of entity. We'll also take this extra print statement out where we were showing the variable, the memory address rather. All right, so here we are. We're in room R1, the entrance. Also here is Mike. We don't see any enemies. Obvious exits to the north. So let's go ahead to the north. So now we're in R2. North and south are obvious exits. Also here's Mike. Now, if I go north, I'm going to be in R3. We expect to see the rat. So we'll go north. Ah, we have an enemy. So we're in R3. Also here's Mike. Enemies, rat. And then we have all our exits to all the different directions. All right, so we've now successfully inserted a NPC into our game that currently does nothing. He's decoration. Good. Just this right here, those 2 lines. We created the rat and we just threw him in R3, the third room.
Why did we used R3 as a way to, oh, because
That's just one of the rooms.
yeah.
Yeah, I just looked at our map here and I said, which of these rooms do I want to toss the rat into? And I said, it's a good place. And inside the constructor for dungeon, that's where I created my instance of all my rooms. Even though we didn't store the instances anywhere, we might change that decision later on. But right now, we create all the instances inside of our, this is actually a good question. So here in my dungeon constructor, I created a bunch of rooms. Now a dungeon only knows about a name, an entrance, and the player. So I created a whole bunch of local variables, R1 through R6, inside of my constructor for dungeon. So these are local variables that die when this constructor ends. I then add a whole bunch of exits to those rooms. Again, I've added a bunch of stuff to R1 and R6, and R1 through R6 are variables that disappear after this constructor's done. All right, so far, it doesn't seem like we're making wise decisions, right? Because these guys are going to die. Why am I using them so often, right? Then we create a rat and we throw the rat into R3. Again, I created this rat. He's also a local variable, right? He's going to be gone at the end of this constructor. So I create something that's going to be gone at the end of this constructor. I then say, okay, R3, which is something else that's going to be gone at the end of this constructor, you get a rat. Then I set the entrance R1. So I let this dungeon's entrance, I set it equal to R1. Then my constructor ends. So when that constructor ended, what died? R1, R2, R3, R4, R5, R6, the rat. I think that's it. Those are all the things that died when that constructor ended. Yet we saw our program run here. Oh, I think it's still running. And we see there is indeed still a rat there. We also see there's an R3. We also see that there's an R6. We also see that there's an R2. All of these rooms still exist. When we see R2 here, we're looking at a room's name. But my question for you is, if all of these variables died when this constructor ended, why are they still alive? So the game started here. This is where we built our dungeon. So dungeon gets built with its stupid name on line 13. The player gets built on 14. We put the player into the dungeon on 15, and then we tell the dungeon to start on 16. Start is our infinite loop, this guy right here, where we just keep asking the player, what do you want to do? What do you want to do? What do you want to do? So my question is, if all of these variables died in the constructor, why do I seemingly still have them in my game? Why are they still around? This is a scoping rule question. Go ahead.
We don't just create them in the dungeon constructor and leave them there, but instead we use them using like the room class and like entity and NPC. So like as we're traversing through the room, we still have what we put from dungeon, the dungeon constructor into that room. So
Okay, it's true that we see that. They are still there. My question is why are they still there?
Which variables are talking about? Like talking about R1?
Yeah, all of these.
Well, it's because you add them to the other rooms,
What did I add to the other rooms?
the exits.
Well, okay, so I mean, I said R1, add exit R2. What did I actually add to R1? Memory address. Not the variable R1, the thing that's stored inside of R1. Now, when this constructor ended, when dungeon ended right here, I'm telling you that R1 through R6, those actual variables, those containers that hold memory addresses, they go away. Who takes them away? We have this thing called automatic garbage collection in Java. So we're not responsible for getting rid of the memory that was associated with these. So when we said our room R1 equals new room, the new keywords are real estate agent. It's going to go get us some memory. So if we were to print out R1 right after this line, we're going to get a memory address. Room at some memory address. Same thing's true for R1 through R6. So after this guy is done, and automatic garbage collection is making its pass through memory, just going back and forth, kind of keeping things cleaned up, 24/7 custodian. He's going to get to the memory address that is R1. So R1 holds some memory address, right? Let's assume it's memory address 123. That way I can remember it. All right, so it's memory address 123. So when automatic garbage collection gets to memory address R23 or 123, he says, should I get rid of this? What do you think? We're talking about R1. R1, when it was built, it got a memory address, a place somewhere in memory. Now, we've already said that this variable R1, the container that held that memory address, he will disappear at the end of this constructor. The memory address will also be potentially cleaned up by automatic garbage collection. So when I'm the automatic garbage collector and I'm walking through memory and I get to memory address 123, and I look down and I say, okay, do I need to get the bucket and sweep this guy in? Or does he stick around? How do I make that decision? When I'm standing there over a bucket of memory and I'm looking at a memory address, how do I decide whether this thing lives or dies?
Whether a pointer exists.
Okay. How do you tell that? Well, what do you mean?
Whether there's some sort of variable pointing to it.
Okay. And how do we determine if the variable is pointing to it? You're right. We're just getting into the kind of the details of it. How do we know if something's pointing to a memory address? Anybody remember what we talked about? I mean, I know we talk about a lot of stuff in here, so I do expect you to memorize every word that comes out of my mouth because it's gold, but you're human, so I get it. We talked about pointer counters. So we have this little variable, like an integer counter on every memory address that says how many things point to this memory address. So when R1 was first born, R1 points to that memory address. We have 1. When we set R2 to be R1's, an exit from R1, R2 was born right here. So he has a pointer counter of 1, but after this line, he now has a pointer counter of 2. Because not only does this variable here link to it, also the memory address that is R1 is linked to it. But we haven't saved R1 yet, so that could be a crash and burn situation. Who ultimately, well, actually, we have R1 right there, so they point to each other, but that kind of creates a weird circular thing. Like, well, R2 can only live if R1 is alive, and R1 can only live if R2 is alive. It's right here. When we say this dungeon's entrance is equal to R1, R1's counter goes from whatever it was up here, which is currently actually 2, it goes to 3. We have something outside of here that still exists. Now, when all these things start dying, those pointer counters get 1 subtracted from each of them. But R1 still exists, and R1 holds a link to R2. So that pointer has a pointer counter still that's greater than 0. R2 links to R3. So his pointer counter has something greater than 0. R3 links to R4, R5, R6, yada, yada, yada. So as the automatic garbage collector is rolling through memory, he's looking down and saying, can I sweep you up? Nope, something is still pointing to you. Even though those variables R1 through R6 have gone away, removing their pointer from you, so removing, decrementing your pointer counter, there's still something that points to you. Therefore, it's not safe for me to get rid of you. All right. So that's why these guys still live. These variables R1 and through R6 have died. Just understand that variables are containers that hold values. The values are the things that are actually the memory addresses. They're the guys that persist. Automatic garbage collection does not go through and clean up variable names. It goes through and cleans up values that are stored somewhere in memory. Variable names are just convenient ways of us referencing a bucket of memory rather than saying memory address, crazy hexadecimal number that we're not going to remember all those things. All right. So we give ourselves nice, convenient names for those places. All right. So we have our game. The rat's in R3. We saw that we can traverse through there and get and find him in R3. But now we are controlling our player. Our player can walk through the dungeon and stuff. We'd like our rats to have the opportunity to walk through the dungeon. All right. So let's talk about threads, and let's also talk about interfaces. So let's start off with this idea of an interface. Now, remember at some point I said something like all hard programs are made up of a bunch of easy things, something along those lines. If you were to crack open the source code for Linux or Windows or Mac OS, you're just going to see a bunch of for loops, a bunch of integers, a bunch of stuff that you'll recognize, right? It's not going to be foreign stuff to you. There's just a whole bunch of it that's doing a bunch of different logic. Now, when I say interface, what does that mean to you in real life? Because remember, one of the things that programming languages attempt to do is it attempts for us to solve problems in the same way human beings solve them in real life. Because, we're the boss here. We're not going to meet computers halfway. We want to stay as far up here in our world as possible. That's why people who've gotten into Vibe programming have, it's opened up a world of being able to program without knowing how to program. You can't do everything, and they're going to hit a wall when you don't have the programming knowledge. How many of you have heard of Vibe programming? Okay, what is it?
Based on,
Okay. How do they do it? Okay, yeah, so they're not coding. Good. You had your hand up for what's Vibe programming?
Would it be something like where they're just like using AI to generate it, and then like not really like looking over to make sure it's okay?
Yeah. So Vibe programming is effectively using artificial intelligence. Now there's tools that, you can do this with like ChatGPT or Gemini, but now there's tools that say, oh, I'm going to just keep the context of your entire directory in mind and I'll help you do stuff. So you can imagine Vibe programming as, let's say you have me locked up in your dungeon. Okay. And I hopefully you see I can code. So I'm locked up in your dungeon and you're just giving me orders. Write this for me, write this for me, write this for me. So you're providing prompts. You're saying, I want an app that does this, that, and the next thing. And then it will go and make it for you. Now, it's only going to make you something that's as good as your prompt was, how clear you were at describing it. And that's a skill you build up. But it's also only going to make it for you as good as that model was trained to write code. Now, do you think these AI models are better than normal programmers at coding? What do we think? Take the temperature of the class. Go ahead. Tell me more about that.
Probably write better syntax, like better organization of code, but like you would be better at solving the actual problem.
Okay. What does better mean in that example?
More efficient.
Okay. Is that you're gonna have the same answer?
Yeah, something along, because like whenever, because I've attempted to use it in some cases just to see what it results in, and like, for example, I was trying to see if it was possible for it to make like an entire player controller off of something that was already built, or see if it could make it more efficient, but it just hits a point where it just can't do that anymore, and it can't make it more efficient, and as soon as it does, just keep it.
And when you say more efficient, what do you mean by more efficient?
Like, as in it just runs better, it doesn't, it's easier on the hardware essentially.
Okay. What do you think?
I think it kind of depends. I think it's better at making, I guess, things that already exist, things that are kind of easy.
Okay.
Then once it gets to complicated things, it just starts making up the variables that it hadn't defined.
It starts struggling.
Yeah.
So what do you think? Does somebody like me need to use AI to write code?
You don't need to, but it can help.
How does it help me? How does it help someone like me?
It can help you with the grunt work if you need to make
100%.
something that already exists, just have it make it.
Right. How many times have I written some of these stupid little functions we're writing? Yes, they're new to many of you, so they seem like, oh, I maybe wouldn't come up with it off the top of my head. Or if I'm writing APIs using like Fast API or Flask, these are Python libraries or whatever, I've written those a bunch of times. It's going to take me 10, 15, 20 minutes, however, depending on what I'm making, to just make it. Just like instant Jello, right? It is in my best interest, if I respect my time at all, to use this grunt worker to go and do that crap for me, right? That's why whenever I have manual labor to do around my house, I call up Ben. Ben comes and lifts crap and stuff. That's what he's good for. We're talking about Ben Wren, by the way, in case you want to tease him. All right, so it's about using the right tool for the job. You think about building like a skyscraper. You know, are those construction workers who are building that skyscraper, are they the ones who designed the skyscraper? No, some architect did with a whole bunch of engineers for making sure that you could have 130 floors in this place and it's not going to fall down. Now, that doesn't make those construction workers' jobs any less important. Ultimately, they're bolting everything together, and if they don't do their job right, everything falls down regardless of how well it was designed, right? So that architect's design job is the design. That's the software engineer, the person who designs how this entire program works. And then that last part is the grunt worker who gets it across the finish line. All right. Now, you're right. When you're solving a complex problem, something that isn't just one of those, you know, go-to moves, you just sit there and you know you can throw 30 minutes at it and it'll be done. When you're doing something that requires some sort of human intelligence to solve a kind of a specific version of a problem. Imagine inside of like Acuity or something like that. We had a thing up there where we're talking about, you know, how are they going to be thinking about using AI? You know, first of all, they are an insurance company, so they have a lot of um, oversight for the things that they work on. There's a people's personal data, things like that. But also there's parts of their system that aren't like, you know, these models were not trained on the way that Acuity does all their things behind the scenes, how their databases are set up and all this stuff. It wasn't trained on that. So you can't expect that an AI is going to write Acuity specific type things. But if you have a program you're writing at Acuity and you have this one class that's just cookie cutter, absolutely. Boss the AI around, tell it to write the stupid thing for you. Just get decent at describing what you want in a prompt, but don't expect it to solve the entire world's problems. How many of you have heard that right now we're in something called an AI bubble? They compare it to you know, the dot-com bubble in like in 2000-ish. All right, what do you think? Are we in an AI bubble?
What is an AI bubble?
Well, I mean, yeah, I mean, um, if there's 1,000 companies doing things with AI right now, 5 years from now, will all 1,000 companies still be around? No, what do you think?
Yeah, I guess it depends on your time scale. If you're looking at like 100-year clip, then no, because the power of this thing will likely scale with the investment that goes into it.
Mhm.
But if you're looking at like a 3 to 5 year clip, probably, I don't think that we're going to get the investment that's been put in out, even at like a marginal rate.
Mhm. And part of it is because of human greed. So this kind of comes back to kind of money's the root of evil. You know, everybody's doing a money grab with AI right now. Just like in the dot-com bubble, everybody and their brother was trying to do a money grab for computer internet stuff because everything was going to be powered by the internet. Well, so the problem is now, so I just asked if we're just using an arbitrary number, if there's 1,000 companies right now that are brand new startup companies using AI, okay, just like the Korova company from last night that I was talking about. Are all 1,000 of those companies going to still be around 5 years from now? Do you think half of them will still be around 5 years from now? I don't think so. But now, will NVIDIA still be around 5 years from now? They're basically at the core of every single AI application. You know, they beat their earnings yesterday, and their earnings were already astronomically high because everybody's using AI chips for their AI stuff. So AI is still going to be very much a part of our life 5 years from now. But it's all these little money grabs that are going to disappear because they're not using AI appropriately. They're trying to rely on AI to solve the entire problem. Yet what we just described in here is that AI is really, really, really good at certain things. You know, I've written an API zillions of times, yet I am not going to be able to write out I'll often just say, you know, give me a quick, fast API structure with one endpoint called LOL. It'll build out the whole thing. It'll import all the right libraries. It'll give me a single endpoint called LOL. And now I have my structure. I can go in and rewrite the LOL to be whatever I want that one to be and put my other 30 endpoints in there myself. But I got the grunt work done because that's not a great use of my time. And if I was racing AI at writing that thing, I'm going to lose horribly. Worse than me in a foot race against Usain Bolt. Much worse. You know, I'm going to spend 30 minutes, 20 minutes, whatever. AI is going to be done in 30 seconds. Or I think I can probably hang with Usain Bolt better than that. Not tons better, but better. All right. So the problem we have right now is everybody is trying to solve the entirety of problems with AI when we still need human intellect, we still need traditional computing, and then AI is a great benefit. It's a power tool that helps us solve some problems. So vibe coding, we're having all these tools that are coming out for vibe coding that allows you to just describe the app you want. And it even has a little interface builder so you can make it look pretty and stuff like that. So you have people that are generating iPhone or Android apps who know nothing about coding, but they can just describe what they want. And these AIs are doing a surprisingly good job for relatively simple applications. Go ahead. Well, I guess I don't know. I mean, because at that point you start getting into the philosophical side of things of, you know, how do you describe human intelligence? You know, first of all, AI is trained as far as the current AIs. So I, I can't necessarily predict what will happen with AI in the future. Will it start learning on its own? Because effectively we've modeled AI after our own brains, but we don't understand our brains. Brains are incredibly complex. So we kind of almost understand like cat brains. You know, human brains are far, far, far more complex, but AIs were created, neural networks were created trying to model the human brain. But right now, all these large language models that are all built on top of the same tensor type of technology, they're trained on our data, things that we generated. Well, you say they can stumble. How can they stumble on solutions?
They have, like, I don't know the exact reason why, but they just do something.
But who told them to do something that caused them to stumble on a connection that was already there that human beings had just not noticed? So, like, I have him working on a project out of the AI lab. We're creating a large language model that's going to act as a quantum computing researcher. Also, he's working on it against my better judgment. Okay, so
You invited me into it.
oh, I was against my better judgment. There was alcohol involved, and
You were drunk.
I wasn't drunk.
You told me don't get drunk. How would there be alcohol involved?
Well, you don't know what I had in my coffee.
You're just making stuff up.
So, anyways, the idea is we're going to create our own local large language model that we're going to train with baseline knowledge to teach him to be a quantum computing researcher. But then what we're going to do is behind the scenes, we're going to give him zillions of quantum computing research papers that have been written. The idea is that somewhere in those research papers, maybe let's just use an example. Let's say 3 different researchers who've never met each other, who've never been in the same room. They've looked into a little bit different angle of the same thing in quantum computing. And even though each individual one hasn't led to a breakthrough, if you put the 3 of those together, maybe it would. Now, because there's so many papers and because all these human beings aren't just in a room with each other, talking to each other constantly, even if they were, we're not that efficient at doing that kind of stuff as humans. If we throw all those papers into a behind the scenes database and we have this AI that kind of understands the discussion points of quantum, we can speak quantum computing lingo with them. He can then go search those zillions of papers way faster than any human being can, and maybe pull in those 3 papers and make those 3 connections because we asked it to. You're absolutely right, but the value that it brought to the table was the grunt work and ability to deal with large collections of data at our command. Now, I can't speak to what might happen 20 years from now. At what point, you know, clearly we are created beings. Therefore, if we're creating these AIs, might we build something that starts, quote, thinking. That's a whole other philosophical argument. What does thinking mean, right? So we can't go too far down the rat hole goes until we're just being really abstract about everything. But let's just generically say, is it completely out of the question that we create a technology that starts doing something that seems to us to be thinking on its own? 100%, that's possible. At least plausible. At least plausible. I guess I can't say if it's possible, but it's plausible because we've seen it happen with us. We do it, right? And you probably heard the thing that, any technology, that's so far beyond someone else is indistinguishable from magic, something along those lines. So who knows? Maybe.
Like, rather than having a human correct it, it can see its output and determine if that's a correct output based off its own model. Then obviously that's
Yeah, and it's so what they're using now is some of the data that's coming in, the prompts. When a human being asks like a follow-up question, which adds some new intelligence into the situation that maybe they weren't trained on, they then incorporate that into their training through like fine tuning or something like that. But at the very least, for right now, I can tell you that all those news things you might read that say such and such AI, has shut down itself or protected itself when the humans decided they were going to shut it down. And scientists are terrified. That's all clickbait. That's not how they work. Yeah, at this point it's sci-fi, but if we roll back to Star Trek years, we have a lot of stuff today that was sci-fi back in Star Trek. So I'm not saying it's never going to exist. It's certainly plausible because we see that we're thinking beings, but that's not where we are right now. But who knows? Maybe we're priming the pump. This is the start of the end. We got Skynet. Watch the Terminator movies, whatever. I'm game. Sounds interesting to me. All right. So interesting stuff. But my encouragement to all of you as you go and look up vibe programming to say, oh, how can I get my homework done? Don't use vibe programming right now. Vibe programming will give you a false sense of competence right now because it will allow you to create outputs that are far beyond your actual coding ability. What you want to do is you want to get a coding ability so that you will appreciate the power tool. That will do all this extra work for you faster so that you're not stuck doing the boring part. You can focus on the interesting part of the problem. All right. But it's really cool stuff that's out there. So don't be afraid of AI. Just understand that AI is not going to replace your human problem solving. It's going to replace the grunt work, at least for now. Maybe 2 years from now, we have a different discussion and we're all hiding in bunkers or something from the deadly robots. But the current technology that they're using to do these things doesn't work that way. It's not going to happen based on the way they're building them now. What's this? All right. So when I say interface, what do you think I'm talking about? What does the word interface mean to you?
It's like computer.
Try to take it away from coding stuff. Just the word interface.
It's like what we see on a computer, like
Mhm.
software kind of.
Okay, user interface. What's a user interface?
It's like the part of the computer that users can actually interact with. It's not software that we can't see or hardware that we can't like.
Well, the user interface would be software, but I mean,
Well, yeah.
it creates a barrier that allows us to connect to the computer. So we use the user interface, which then translates what we're doing into things that are meaningful to the computer. What were you going to say?
Even if there is kind of a coding aspect to it, it's still technically based because you're still.
Okay, let's say I just went to Target or whatever and I buy a toaster. All right, buy a toaster. And there's how many of you would expect that somewhere on that toaster is going to be a wire coming out of it with a little two-pronged pluggy thing on the end of it? And you look at that and you say, well, what is this? Is this something brand new that just came out 5 minutes ago? What's that for? So plug it into one of these guys. Well, what's that guy? Is that an interface that allows us to take this guy and have it interact with the electricity of this building through that plug? And it has to fit that plug. So if this thing had 6 prongs on it, one of those, the European ones, right? It's always terrible when I go on these cruises and it's one of the European cruise ships and they don't tell you that. So you show up with all of your US plugs and you can't plug it into anything. And then they sell you the adapters for an arm and a leg plus your other foot probably. So that's an interface. It allows us to take this and connect it to whatever's behind that. All right, and it has to be compatible. So what this interface tells us is it says you have to have something with 2 prongs that are the right shape that will fit into that. And for some things, you need to have 3 prongs because it needs to plug into the ground. That bottom thing there is the ground because it's probably a piece of equipment that is using more power that if something went wrong, it could be a problem. Right? So those are things that will have the extra prong because if something bad happens, you want it to be grounded so the house doesn't explode. Well, after it burns, then it explodes. So interfaces are the same thing. Interfaces in our programming languages allow us to describe a compatibility layer. It allows us to say, okay, well, if you want to write something that can talk to things that are compatible with this interface, you must build code that has the right number of prongs, the right shape of prongs, that kind of stuff. All right, so if I go to documentation here, so let's go to something called the runnable interface. Well, let's just do runnable Java. All right, so here is the runnable. So we see that runnable is an interface. And it's actually a very boring interface. This interface says that you have to write one method. You have to have one prong. The prong must be called run. And it must take no parameters. And it doesn't matter what you put inside that run function. That is the function that we're going to expect to be able to call when you are saying you're compatible with the runnable interface. So if you say you're runnable compatible, we know that we can say, we want you to call your run function. You might have 50 other functions, but you have to have at least the run one to be compatible. That makes sense? All right, so now as we look up here, we look at implementing classes. So forget about sub-interfaces right now. Sub-interfaces are effectively inheritance, but for interfaces. Where we could say, okay, well, you're USB 3.1 compatible, but are you 3.2 compatible? We're going to inherit from 3.1. You 3.2 has everything that 3.1 has, but you also have to have these other 2 things to be compatible with that. So they let you do inheritance for interfaces for things that are supersets of something that already exists. But these things called implementing classes these are classes that claim to be, well, not claim to be, that have said, I play by the rules. I am compatible with the runnable interface, which means that every single one of these classes here, regardless of what their name is, every single one of those classes will have a run method. It has to, if it's going to implement the runnable interface. So we said we were going to talk about thread. So if I click on thread here, we see that thread implements runnable. So if I scroll down to my functions, my methods that live inside of thread, at the very least, I should find one called run. Those are the constructors. There we go, right there. Run. So a thread's run function does nothing. So if you create a thread, so for example, let's go into our code here. Well, first of all, let me just show you that thread is in the top level. So thread lives inside of java.lang. So it comes with basic Java stuff. You don't have to import anything extra to work with threads. All right, so we're going to go into this guy here. We've decided, okay, well, humans control our players, but we want the computer to control our NPCs. So we're going to go ahead and say that an NPC is going to extend an entity as well as a thread. It's both of those guys. It gets everything from entity and it gets everything from thread.
Double inheritance. Python Java didn't do that.
We're getting there. You're ahead of me. So take it down that path. I mentioned last time that C++ had something called double inheritance. We want entity, and frankly, this is kind of why I was going to monsters. But he made a good point. So let's we'll keep running with this. So I mentioned last time that C++ supports double inheritance. That means one class inheriting from two different sources. All right. Now let's assume, even though we know this isn't the truth, but let's assume that inside entity we had written a run method. I mean, we could even do it here. We'll just. Yeah, I'm going to be deleting it. All right, so entity has a method called run that prints out woot. Now I've told you, well, we also just looked at the documentation and saw that threads have a method called run. In fact, that's a super, super, super important method in threads. All right. Although actually it's not the method you call. We'll talk about that. But it has to be there. And it's where you put your logic. But if we say that an NPC extends both of these guys, all of a sudden, whose version of run do we get? They're both providing me a version of run. Because what we've known about inheritance from last class was that inheritance says you get everything that your parent has by default, unless it's private. If it's private in your parent, then they don't hand that off. But if it's protected or looser, you get all those things. Well, now I have in my example that he's right, does not work in Java. I'm trying to inherit from two separate things. And both of them have a run method. Whose do I get? That would be the decision that the language designer would have to make when they're deciding whether or not, to support double inheritance or just say, yeah, let's not allow this so we don't have to make this choice. Kind of make sense? But that allows us then as programmers to fix our code to still accomplish everything we're wanting to accomplish without having this complexity. Go ahead. You could do that. So something he said is, well, can we have, so we can say NPC extends entity. We can go up to entity and say that this guy extends thread. We could certainly do that. We do have to then ask ourselves, well, what was our idea of entity? And will all entities potentially be threads? Well, all of a sudden we've said that players now have the thread ability. Now, that doesn't mean we have to take advantage of that ability. We could just decide that, we're not going to write the thread special code for players. But at this point, by saying entity extends thread, we have at least given us the option with players for them to support a thread. Now, we could even make an argument for why a player might want a thread. Perhaps, we haven't really talked about threads, frankly, at all at this point to be able to make that argument. But, typically in video games, there's kind of this overarching thread that's sometimes called the game loop. And the game loop happens maybe once per frame, or once, a lot of game engines limit it to 60 frames a second. So every 1/60th of a second, the thread, the heart beats, and something, we have an opportunity to do something every 1/60th of a second for 60 frames per second, trying to maintain that. Which means that 60 times every single second, that run method might get called, and we could choose to have something happen specific to a player. So maybe a player has, in the game, has a disease or something like that. And, the disease hurts them a little bit over the next 10 seconds. Well, we can have the global game loop handling that and saying, okay, player, you get hurt, you get hurt, you get hurt, you get hurt, and you have thousands of players in the game. So now all of a sudden you've put the onus on who is going to handle all those individual little damage things. Do we have effectively the game god at the top just zapping things all over the place? Or do we have the individuals handle it, where a player has their own little mini game loop? And their own little mini game loop has that can just do the damage only to just that single player. That's not unreasonable. We can make that decision. Okay? Now, let's see. 4 minutes. What can I accomplish in 4 minutes? Okay. Let's do this. We're going to go with your decision to have entity extend thread, which means I have to have a run method inside of entity. If I don't have this guy in here, it's going to yell at me. So just doing this one thing, all I've added to the program right now is extends thread. I don't think I've done anything to MPC. So I don't get an error. Why? We said that anything that's a runnable has to have a run method. We looked at entity. We see that, well, entity extends thread, so don't I have to write a run method? Clearly not, my game's running. Why didn't I have to write a run method? Go ahead.
Because
Thread comes with one. I'm extending thread, so I get thread's run method that doesn't do anything. Now, if I, instead of saying extends thread, if instead I said if this guy, if I instead said that this guy implements runnable, now I'm advertising myself as following the rules of the runnable interface. Instead of saying, I am a thread, which already follows the rules of the runnable interface. His run method might not do what I want mine to do, so I might choose to override it, but at the very least, I get it. Because the guy I inherit from already is compatible with runnable. So if I do this, now it's going to yell at me. It says it does not override the abstract method run. It's treated as an abstract method because you have to write it yourself. You don't just get it from the interface. So what we are going to end up doing is we're going to say that an entity is going to extend a thread, looking forward to that maybe the difference that we work with for players versus NPCs and how we utilize threads for both of those, because both of them have the capability of being threads. Right now, a player gets a run method that does nothing, and a NPC gets a run method that does nothing. Now, if we want to just see in our last minute, just a quick example, I'm going to go into player here. I'm going to say, well, a player extends entity, which extends thread, so therefore a player is a thread. I can write my own public void run method. And I'll just do system.out.println LOL. And then what we'll do out here is as soon as our dungeon is told to start, we're going to go ahead and say this dot the player dot start. That's the magical method that threads have that knows how to talk to the operating system to do thready things, which we'll talk about next time. Oh. Class entity extends. Yes. All right, so it's blocking right now, so we're not seeing the LOL. I'll go ahead and type in look or whatever, and we're gonna see another LOL somewhere. Is it off the screen already? So we have this thread in the background that's trying to print out LOL, LOL, LOL to the screen, but we're blocking, waiting for the user to type in some information. All right, so what we'll do is we'll come back next time and we are going to actually make our rat move around randomly through the system. If you wanted to mess with something over the weekend, go through and try to write your own run method for either maybe an NPC for it to do what we just did. If we move this into the NPC, it wouldn't be blocking. We'd see it on the screen. Play with threads a little bit, read up on threads. We'll be having our game making a pretty big leap on Tuesday. Questions, comments, concerns, bribes? I'm not giving it as homework, but I'd encourage you to look into it. And what I'll do is before I post the code, just so you see a better version of this example, I'll move the run method over to NPC instead of player. And then as we add the rat to the game and dungeon, we'll tell our rat to start. I think this should bypass our nope, we're still getting blocked.
Does start.
Say this again.
Does start.
Yeah. I'm gonna try system.error. Let's see if it
I don't think I had to call that to get my thread to start.
you 100% do. That's how threads start.
I just forgot that. But yeah, never mind, you're right.
Yep. No, it's not getting into this terminal. If we ran this out in a normal terminal, I think system.error would do it. But we're blocking the thing at this point. But right now, this rat should be printing out LOL over and over and over and over again as fast as that thread can. This is effectively an infinite loop. Oh, actually, no, it's not. I'm sorry. Now we'll make it an infinite loop just so you can see it real quick since you're still standing here. While true. There we go. So you see how it's printing out LOL over and over again? But I can probably type in look. Let's see if I made a dent in there if it got my thing going. What's up?
I was gonna be question Tuesday because I was sick and I was at the clinic.
Okay.